Hi everyone, I'm Neel Gandhi. I work as a machine learning software engineer at Google and wanted to talk about high trust healthcare AI, privacy, performance, and platform thinking. Today, I want to talk about something I think is becoming more important than foundation model quality. That is, how to develop trust in production AI systems, especially in healthcare. Healthcare organizations in 2026 usually can create an AI demo. They can summarize a note, extract field from PDFs, classify an image, and do bunch of agentic AI stuff. The real challenge starts after the demo. The question becomes, can these systems be trusted with sensitive data, variable real world inputs, workflows that can actually affect people? My core argument is that trust is not something that you can get automatically from a powerful foundation model, but it has to be engineered. And in healthcare, that means thinking beyond model accuracy, precision alone. I will frame this talk around three ideas, like that is privacy by design, performance you can prove, and platform thinking that lets uh, trust scale across teams. Uh, there is no specific product that I would be discussing, but it would be like a practical blueprint on various systems that can be used to pivot from isolated pivots to systems that are safer, more auditable, and more deployable. Uh, Moving to the next slide. So we have trust gaps. So when people evaluate AI systems, some often ask what which foundation model to use. But as foundation models are becoming better and better, the question that is important to ask is like, what system surrounds the model? Because trust is not just a model property, but also a systems property. A model can be impressive in isolation and still be unsafe in the AI era, like during the agent deployment and stuff. The things that actually create trust is the surrounding systems. What data came in, what transformations happened, what prompts or rules were applied, what output was produced, what checks were run, and what happened next. That is why I can say trust is a system property. There are three practical requirements here. First, if you can see in the diagram, we can use tools like LangFuse. On the left part of the dashboard, you can see that first we need to trace every step. If a clinician, compliance, or engineers ask how the system produced the output, you need an answer. So tools like LangFuse or OpenTelemetry helps in with that. Second is if something is failing, so we should be able to inspect failures. You cannot improve what you cannot diagnose. So if summarization fails or PHIA information leaks, you need to localize failures quickly. So in case the user assistant response that we see on the right does not work as expected, we should be able to inspect the failures and uh, quickly fix it. The third is prove safety, not just claim it. That means you need artifacts, logs, evaluations, and routing decisions and auditability on a fixed golden data sets or stuff to prove that your system is working as expected for like de-identification or redaction or summarizations and various other stuff. So the example on this side shows traceability infrastructures with tools like LangFuse and OpenTelemetry that can make AI pipelines more observable. Uh, and yeah, the in other words, the path that AI agentic uh, workflows or AI workflows in general take is matters as much important as the output itself, and in developing trust. Uh, Moving to the next slide. So, what is the core thesis of this? Is like we first is that we should have privacy by design. So, if privacy breaks, the trust cannot begin with. So, in healthcare, this is foundational. If a system cannot control access to PHI isolated sensitive workflows and make data movement explicit, then nothing else matters. So we should have a privacy boundary with identification of PHI as well as de-identification. Second is like performance you can prove. So as you establish privacy boundaries and use AI, It is not enough for a system to just look in good in demo or feel good after a handful of example testing. You need a measurable evidence that it works under realistic conditions, and you need thresholds for what when it should not be used. So, proof gates like traces, evaluations, and failure inspection mechanisms, and help with establishing a system which you can prove. Third is platform thinking or platform reuse ability. So, even when let's say once a team in a big or build something safe and effective, uh, many other organizations or teams still fail to scale because the trust mechanisms are not reusable. So every team should rebuild privacy evaluation routing algorithms observably by reusing the components from other systems which are working. That if it is not happening, that slows down the adoption as well as increases the risk. Here we will be discussing a small framework design which encompasses privacy boundaries, proof gates, and platform reuse, all reinforce one another, and proving that trust is not just one control; it is an interaction of this layers, and it is made of privacy, proof plus platform to establish a proper trusting layer. Uh, Moving ahead, we have a privacy boundary. So you can see that when people talk about privacy in AI, they often straight go to redaction, but privacy boundaries are broader than redactions. A privacy boundary means every transition of sensitive data is explicit, controlled, and auditable. You should know where identified data enters, where it is transformed, and where it leaves, and which systems or people uh, can touch it. So the idea is this. The second idea is like having a PHI zones. So I find this framing very helpful. Think of systems of as having eight regions. One region may contain raw identified data. The another may contain de-identified outputs. The another may contain reviewed and approved artifacts by humans. Those regions should not blur together by accident, and we should have a privacy boundary of each at every step of the systems. The third idea is minimal access. Every user, tool, service, and model should receive only the least amount of information required for the task. Not all models need raw identifiers. Not every downstream team should see the original document. Not every reviewer needs every field. So with open source, like one of the examples of this tools is Presidio. So I have shown that on the right of the slide. So it helps as a good illustration. It shows uh, raw text containing identifiers and then a redacted de-identified output. That is a useful control. But important parts of architecture is not just that redaction happened, but it is a system that can demonstrate what was found in terms of PHI, what was removed in terms of PHI, and what was the residual risk remains in this, and where the cleaned output is allowed to go. That changes privacy from an informal promise to an enforceable design pattern. So, yeah, this is about all about privacy boundary. Next, we will be talking about modalities. So, in terms of use of multimodals and use of different other foundational core AI models, it is very important to understand that sometimes one size or one system does not fit all paradigm fails. A lot of teams think de-identification is a generic operation, but modality matters enormously. So sometimes text is different from PDF risk, and both are different from uh, DICOM risk. So with text, you may use entity recognition, pattern matching, or structured rules to detect names, dates, identities, and so on. With PDFs, the problem becomes harder. may have like mixed layouts, scanned text, embedded images. The identifiers may not even be in machine readable text. With DICOM and medical imaging, you have another class of problem. People often remember to scrub metadata, but images itself may contain burnt in identifiers in the pixels. So as you can see in the image on the right, there is some burnt in identifiers in the pixel itself, like the name, date of birth, and stuff. So if you uh, only clean the headers and ignore the pixels, you can still leak PHI. So that is what exactly this slide is pointing to. The image example contrasts the real and redacted views, and the caption of the note says that it was achieved manually, like through a custom script using Python library. The key lesson here is privacy controls must be modality aware. So handling uh, DICOM examples properly with bond identifiers is super important. So the first is for the one size fits all fails for two reasons. First is the location of risk differs by modality. In case of text, it might be different. With PDFs, it might be layouts. With DICOM, it might be burnt and identifiers. So your the privacy pipeline should be composed of specialized controls for handling different kinds of data and not just one universal sanitizer for the same. Moving ahead, we have proof kits. So, so in production healthcare, you need proof kits. These are explicit checks that determine whether a system or output is allowed to move forward. So the first concept is eval contract. I'll say eval contract defines what success means for given use case. Concretely, it means what metrics actually matter. So, like it might be PHI detection, clinical relevance, uh, tracing hallucination and stuff. So you need to be clear with what metrics actually matter. What test sets represent the real workload. So you might be taking clinical notes, you might be taking cancer images and stuff, DICOM images for various images. And so what failure type, and third is what failure types are unacceptable. Like you can't accept it to have hallucination failures and stuff. And how is the risk stratified? So this is what is composed of an eval contract in general. The second is after you have like an evaluation report, like as shown in the slide. Like with deep eval, we were which is one of the tool, I was able to generate this report. So with this, you can be when we go into the second concept, that is no go threshold. So these are the hard boundaries. If system falls below a threshold, or PHI detection, faithfulness, calibration, or routing accuracy, it should not ship us, or it should not just auto release outputs. We need mechanisms to have a no-go mechanism as well. So you can see here is that faithfulness just didn't meet the standard. So it should not be shipped directly, but we should have a proper release mechanism for the same. And the third concept is safe abstination. So this is extremely important in healthcare. Sometimes the most trustworthy behavior is not to answer confidently. A good system should know when to abstain, or escalate. So it's with use of open source tools like Deep Eval, we are able to generate such healthcare evaluation report at scale, uh, and it helps us to enforce quality from multiple dimensions, not just a single score like accuracy or precision or hallucination and stuff, which helps us to make actual operational decisions at scale. Uh, Moving to the next slide, we have uh, human reviews. So definitely, after even if your system is working perfectly, you should have a layer of human reviews. Human reviews help with, first of all, it helps with manual labeling of something, of creating data sets for evals. So let's say that a common mistake in AI deployment is to think the choice is either fully automation or no automation. In reality, the most practical system use graduated automation that starts with confidence routing first. So low risk, high confidence output may be allowed to flow automatically, and higher risk or lower confidence output should be routed for human reviews until it's the pipeline is stabilized. Then comes the risk tiers. Not all outputs are equal. A harmless formatting suggestion is not the same as a diagnostic summary or an extracted medication list or a patient facing clinical recommendation. The review burden should reflect the consequence of error for a human. The third point is a clinical approval. In healthcare, the trust often depends on preserving human accountability at the right points. The goal is not to have no clinical judgment, but it is to support it with systems that surface uncertainty, route exceptions, and reduce manual burden where appropriate. The annotated image on this slide shown through Label Studio illustrates another important point. Human review is not just only for production approval; it also helps us how you can improve the systems. Review data can feed better evaluations, better rubrics, and better model tuning. So humans play two roles. It is they help in checking the system's post production as well as helping the system develop through eval data sets. Uh, that is much stronger design than pretending that model can handle every use case equally and keep the human in the loop component intact. Uh, Moving to the next slide, we have platform thinking. So, if uh, if privacy, if we have privacy and proof are the controls, platform thinking is how those controls scale. So, a lot of healthcare organizations get stuck because each team builds its own bespoke pipeline. One team builds a summarizer, another builds uh, a different summarizer, another team builds imaging workflows for summarization, and each team independently rebuilds audits, logging, validation, review, and compliance control. That might not scale well. The better platform is to build reusable DAX, that is direct acyclic graphs, shared controls, and portable apps. Uh, when I say reusable racks, mean that core steps of the workflows can be standardized, like ingestion process should be standardized for a particular modality, like medical images, scanned PDFs, clinical text, and de-identification process can be standardized with a set of fixed tools as much as and then comes the inference stage with AI, and then a validation stage with some traceability tools, and reviewing with human reviewers and auditing the change. This can be, if possible, can, are the fixed components which can be reused across teams. So shared controls means privacy checks, evaluation gates, and routing policies are implemented once and applied continuously. Portable apps means teams can deploy use case specific workflows without reinventing the governance layer each time to follow HIPAA guidelines and FARO agreements. The pipeline diagram shown in this slide makes that concrete. Multiple inputs like clinical text, scanned PDFs, and medical images flow into a common pipeline with standardized stages. That's exactly how the architecture reduces duplication as well as improves trust. This is why I think platform thinking is important engineering efficiency improvement step, and also a trust multiplier. At the end, we have readiness scorecard. So, in terms of privacy, before deploying healthcare AI workflows, I think teams should be able to basically confidently answer five questions. First is the privacy boundary. Do we exactly know where PHR enters, how it is transformed, and where it is allowed to flow? Second is eval thresholds. Do we explicitly have a matrix to track minimum acceptable performance for each given use case? Third is review routing. Do we know which outputs are being auto released, which are being escalated for human review, and why? Fourth is the audit trace. Can we restructure how an output was produced and reviewed through traceability tools and stuff? And fifth is drift response. If the data distribution or performance changes over time, do we detect it and how do we respond to it? Uh, there is one slide that shows an evidently example of drift detection. Performance is not static, accuracy can drift, inputs can shift, and model that looks safe like prior to weeks in this image may not be safe in week 3. That is why readiness is not just a one-time uh, audit or certification, but it is an ongoing operational discipline that should be followed. If a uh, teams before deploying to production should be able to confidently answer these five questions to build high trust AI systems. Lastly, in terms of some open questions, the first is how do we define a real privacy boundary in multimodal pipelines? Uh, as we combine uh, text scans, imaging, and privacy becomes a cross-modal systems problem, we need better designs patterns here. Second is which matrix matter most: accuracy, faithfulness, calibration, obstinance as proof gates. Is it like this can be a combination of all of this? Different use case may need different answers, and I think the field is slowly maturing on this front. The third is output should auto release or and which must route to human review. So that is not a foundational model question. It is a workflow risk accountability question. So teams should identify exactly where the model is failing and which decisions should be routed for human review for accountability and proper um, developing high trust AI systems. So I think that's all the open questions right now for from my end, and I think trustworthy systems are built through privacy by design, performance you can prove, and platform thinking that lets you guarantees that scales well for millions of users. Thank you.